So far we have seen the implementation of graph as list. We now need to explain test graph the Java. Maybe before that, let's go back to the document because it explained the example a little bit before we look at the code. Okay, so far what we have seen is example 1, which is essentially the implementation of graph as list along with its two inner classes, vertex and edge. So the next thing we want to learn is how do we use this class to test our concepts that we have learned about graphs. So it says example 2, test graph has been given to you and it shows how graph as list may be used. You can use the following example graphs for which the data files are also given. We're going to see the data file in a moment. They are given inside text files, graph data A corresponding to GA, graph data B corresponding to GB, graph data C, and graph data D. So we have 4 graphs here that we can use in this lab and also in lab 11, which is just an extension of this, to see how to use actually the graph class that we have just discussed. Now here it says study carefully the implementation of init graph method inside the test graph class. Okay, this method can be used to read data files representing both directed and undirected graph to instantiate a graph object. Okay, if you check the lab 10 folder and go inside the project folder, you see there are 4 data files given to you: graph data A, graph data B, graph data C, and so on. These data files correspond to the graphs that we saw in the document. Okay, so the document is actually going to explain the content of this data file. Let's go back to the document. I hope I can show both of them together. Okay, probably I can. Okay, it says that this method can be used to read data files representing both directed and undirected graph to initialize a graph. It assumes, meaning the method init graph, it assumes the following. The first line in the data file contains the size of the graph, that is the number of vertices. As you can see here, we have 9, followed by the letter D for directed graph or U for undirected graph. So in this case, you can see U is followed by the size, and it's following the size, so indicating that this data file is for undirected graph. As we saw, graph A is actually an undirected graph. Okay, this is an undirected graph. So we're going to see that for GB and GD, the value there is going to be D rather than U. U is for undirected, as you can see here. This is U. Okay, so that is what the first line is showing. But it says followed by yani the D or U is followed by an optional. It's followed optionally by the labels of the vertices. So you may see or you may not see the labels for the vertex. For the ones we have opened so far, there is nothing other than this comment. But I think if you open GD, for example, let's open GD. Also, nothing is followed by D, but maybe it's GC then. Okay, yes. So you may optionally, these two values, the size and the type of the graph, may be followed optionally by the levels of the vertices. Okay, there may be this or not. If there are no labels, you will only see the size and the type of graph. Okay, so this is one. The second thing is the rest of the lines in the data file contains 2 or 3 integer values each, representing the ages of the graph. Okay, if the third integer exists, it actually represents the weight of the age. So essentially what we are saying is you will be seeing either 3 values here for each line. So the first value is V0 for the age, second value is V1 for the age, and in case you see a third value, it is the weight, because for some graphs there could be weight. So for the rest of the file, I think there are no weight, just two integer values. So this is basically the information about the graph. The size, the type, followed by the ages. Okay. You will notice that for undirected graph, if we can go back to the GA, for undirected graph, each age is going to be repeated twice. How can I show both together? Yeah, for example, the age 0, 1 is here, 0, 1. But when you come to vertex 1, we will also count another age 1, 0. As you can see, there's 1, 0. Okay, there's 1, 4. There's 1, 3. Okay, 1, 0. 1, 2, actually I missed that. 1, 2, and 1, 4. Okay, so each age for undirected graph is going to be counted twice in this file. Whereas for directed graph, of course, the arrow indicates where the age is going, so it's going to occur only one time. Okay, now the point is, inside the main class, there is a method called Init graph. It is this method that is going to read these data files to actually create a graph for us. So let's go to the file, test graph, and we're going to skip the main method. Notice that the main method is calling that method. This is the first line here. So it's a graph as list, graph equal to init graph, and you give the name of the data file containing your graph. So here we are, giving it the first graph, the data file for the first graph, GA. Okay, so let's go to this method and see how does it actually read the file to create a graph as list object. So this is the init graph method. Again, the comments here are explaining exactly what we saw there in the document. As you can see, it receives the name of the text file. So the first thing it does is it creates a scanner object called reader, equal to new scanner, new file, and you give the name of the file. So this will create a scanner that will go through the text file. Okay, we have a number of variables here. A graph as list object, not yet created. Variables to be used for V0 and V1, and size, and weight in case there is a weight. And string variable line, which will be used to read a whole line. And then an array of string, we're going to break that line into different tokens. So we call the variable tokens. Okay. Now the first thing we do after opening the scanner object, after opening the file using scanner, is to read the first line. This reader.next line will give us the first line. We know that first line contains first item, the size, second item, the type of the graph, and possibly list of labels. So the statement here is saying line.split based on space, the line that we have just read, split it based on space and save the result in this array of strings. Okay, I don't know why yeah, okay. So the line will be broken after reading it. It will be broken using the split method. We explained the split method when we look at file IO. Okay, and also when we did AVL3 lab. So now our tokens are inside this array. We know that the first token or the first item in that array is the size, but it is as a string. How do we convert it to integer? Integer.parseInt token at 0. Save your result as size. So we now know the size. Next is going to be the type. So token at 1, check, is it equal to D? Because if it is not D, then it must be U. Based on this, we are going to create an instance of our graph as lists, either as a directed graph or as an undirected graph, just by passing true or false to the constructor. Okay, so if the second argument is D, then our graph becomes new graph as list, size true, meaning create an undirected graph. Otherwise, graph equal to new graph as list, size false. So either way, at this point, the graph has been created. The graph object has been created, but no vertices has been added, no edges have been added, just an empty graph. Good. Now the first, okay, before we start adding actually, we need to check, are there labels? Because our first line may contain labels. So this is what this is saying. If token.length is greater than size plus 2, okay, so meaning there are labels, which of course there will be size number of them, plus the two values for the size and the type. So if there are this number of tokens in our array, after splitting the first line that we read, then definitely there are labels. So in a loop, we're going to create the vertices and add them to the graph along with the label. So in that case, we will use the first version of the add vertex method. If you remember, it accepts a weight, which, as I said, could be just the level. So our graph, which is empty, add vertices to it by saying for I from 0 to size, graph.add vertex, and you give the particular level. Okay, so in the case of this graph C, you are saying add vertex A. So the level of that graph, remember, of course, we don't give the ID when we create a vertex. The system will create the ID. So it will create a vertex of ID 0 and of level A. Okay, then again repeat the loop, add vertex, so the next vertex will have ID 1 and level will be B, and so on. So by the time you add all the 7 vertices, they will automatically be allocated these levels as well. Okay, but typically we don't have labels actually, as we saw in the other 3 graphs. So this line may not, this loop may not execute. Instead, it is this one that may execute. So here it's saying if there are no labels, just call the simpler add vertex method. That one doesn't take any argument, because remember, the system will give the IDs, not us. So just say graph.add vertex. from 0 to size, or size minus 1. So it will just create the vertices and give them IDs from 0 until size minus 1. So at the end of this if statement, we will have added the vertices to our graph. Next is to add the edges. So for this, we have to be reading the information from the file line by line. So while reader has next line, we read the next line, split it into tokens. Okay, the first token, the one at 0, will be V1. So just convert it to integer and save it as V1. Second one will be V1. If there are more than 2, meaning there are 3, then the third one is a double value, and so we're going to use double.parseDouble, and we will save it as weight. In that case, we will call the first add age method, the one that takes 3 arguments. So we say graph.addAge, v0, v1, and weight. Otherwise, we call the simpler add age method, just giving it v0, v1. Okay, then go ahead and read the next line and do the same. So at the end of this loop, our graph will have been created with all the vertices, with all the edges, according to the data file. So all you have to do is close the file and return the graph. Okay, so we don't create a graph object as we used to create other data objects, because there are many things involved. After you create, you have to add vertices, you have to add edges. So we simply call this method. Take my data file, create a graph object, and return it to me. So at this point, we have a graph object created. Now we're going to give the user options to test some of the methods. The first option is just print the graph. Second option, print the traversals, both the breadth first and depth first. Okay, and here is saying get predecessors and successors, get incident and emanating edges. These are the only methods we are testing here. Okay, we will run the code. Actually, it's already running. I will run the option to show you it works for the undirected, and then we will run it again for the undirected, and you will see what I mean. Okay, so in the option for the printing of the graph, nothing needed, since the graph has a toString method. Just pass it to print line and it will be printed exactly as we described. For option 2, we say breadth first, and you call breadth first method, sorry, depth first, giving it the starting vertex, which is 0. Okay, and then also call breadth first, giving it the starting vertex to be 0. So either way, you're going to see how the elements are going to be listed, exactly based on the traversal we already described. Okay, what about printing the successors and predecessors? Well, successors and predecessors are for a vertex, so we have to ask the user to give us the ID of the vertex. This is what we are saying here. Enter the ID of a vertex to print its successors or predecessors, actually, and predecessors. So we read the ID, and now we are saying the successors of the vertex with this ID are graph.getVertex at ID. So this will give us a vertex. Now call the getSuccessors method. Remember, this is going to be a vertex. Well, a vertex has getSuccessors method, so it will get the successors and print them out. Successor is going to be an array list, so the output here is going to be an array list of the successors, okay, which are going to be a list of vertices. Similarly for the predecessor. Okay, graph.getVertex at ID dot get predecessors. All right. Option 4 is to print the emanating and incident edges. The same idea. You have to get the ID first from the user, then you call graph.getIncidentEdges and you give it the ID. or graph.get emanating edges, and you give it the ID. If you wish, you can also call it on the vertex by saying graph.get vertex at ID dot get incident edges. In that case, you don't need the parameter. Okay, yeah, you can do it based on the vertex or based on the graph. Both of them have get incident edges method and get emanating edges method. So this is the graph. It's already running as we've been seeing all along. Now I just want to show you, for example, if you want to see the traversals. So option 2 will print the two different traversals. So this is the depth first, V0, V1, V2, V5, and so on until V8. I don't know if you will be able to compare with what we will get manually if we do the traversal. Let's attempt it. Remember, at least depth first we can do it mentally. So we may not be able to see all of it, but at least you can see part of it. Okay, so we start from 0. So you can see 0 there. We go to 1, we go to 2, we go to 5. So you can see 0, 1, 2, 5. So we get stuck, so you're going to backtrack, and go to 4. So you can see 4 is here. Then 6, okay. Then 3, then 7, and 8. As you can see, 3, 7, 8. This is the depth first traversal. Breadth first is similar, but using a queue. Okay. Now to test the others, we can do it with the undirected graph, but I prefer to do it with directed, because then you can clearly see where are the successors and where are the predecessors. What are the incident edges? What are the emanating edges? Because for undirected they are a bit the same. Successors and predecessors are the same. Emanating edges are the same as the incident edges for undirected graph. So let us quit at this point, this example, and go back to our test program. Just change this to graph B, graph data B, and run the program one more time. Run file. We could have just run actually, because there's only one main class in this project. So this is the menu. Choose option 1 to print the graph. So this is our graph. You can see the difference between directed and undirected. Here now the V0 and V1 are separated by an arrow, not just a dash. So this is the same graph that you are seeing here in GB. You can see, for example, for V0, there are two emanating edges, V1 and V3. Okay, so you have 0, 1, 0, 3. For 1, however, there are 3 emanating edges, 1, 3, 1, 4, and 1, 6. That's what you are seeing here, 1, 3, 1, 4, 1, 6. Okay. Vertex 5, however, has no emanating edge at all. Therefore, its linked list is empty, and so on and so forth. So this is exactly what the printing will do. It will print the graph exactly as it will be represented in our 2 arrays. One array is for the vertices, the other array is for the emanating edges. Now I want to show you, if we ask vertex 4, for example, what are your emanating edges? It should say 4, 2 and 4, 5. Okay, so let us try that. Option number 4. Okay, so first it's asking, give me the ID of a vertex to print its incident and emanating edges. So both actually. So the ID is 4. Okay, and here are the answer. Say the incident edges are 1, 4, 3, 4, and 6, 4. As you can see here, incident edges 1, 4, 3, 4, and 6, 4. The emanating edges, on the other hand, are 4, 2, 4, 5. As you can see here, 4, 2, 4, 5. So this is the idea. If you want to see the successors, The same thing, option 3 will give you the successors and predecessors. So the predecessors, so enter the ID of the vertex, still vertex number 4, and you can see it is telling you the successors are V2 and V5, and the predecessors are V1, V3, V6, exactly as you expect. Okay, you can see that the successors of 4 are 2 and 5, vertex 2 and vertex 5, and the predecessors are 1 because we have 1, 4, 3 because we have 3, 4, and 6 because we have 6, 4. Okay, 1, 3, and 6. This is basically what the example is doing. So now what are the tasks you are supposed to do based on this example that I have given you? Okay, now the first task, as usual, is manual, just to help you to learn how to do this graph operations manually. Okay, it says manually find the depth first and breadth first traversal of graphs GB and GC manually. Okay, so this is the graph GB and GC. Okay, this is GB and this is GC. Manually find their traversals. So deliberately you are asked to do both for directed and undirected graph. You can get the answer by running the program, but that doesn't help you in an exam because you need to do it manually. Okay, so that's the idea. Do the traversals manually and see if you can get the answer by running the code. Okay. Yeah. So after that, it's a run the test graph example to confirm your result. Okay. So this is important, Shabab. Now, as I told you, the lab tasks are being divided into 2. For this lab, you only need to do this task 2, and of course the manual one in task 1. For lab 5, after I have explained more things in the lecture, you will do the rest. Okay, task 3 basically, and there are more manual things to do in task 4. Okay, so our concentration for this lab is simply here, and that is just what I'm going to explain, and then you will try to do these methods and you can submit them under lab 10. So here is the task. It said add the following methods to grab as list class. 1, get ages. Okay, get ages returns all the ages in the graph as a single array list. So far we have methods that can give us emanating ages if we give it a vertex ID, or it can give us incident ages if we give it again the vertex ID. Now we want all the ages. How do you do that? It's really very easy. All you have to do is, if I can go back to the beginning, this is your graph. We want all the ages, okay, in a single array list. So in your method, just create an empty array list and then go through your adjacency list array. For each array list, add it to your array list using the add all method. You don't have to go through them one by one. As I showed you, you can add a whole linked list or array list to another array list. But the add all method will do it for you. Just take it. Or if you prefer to do one by one, of course you can use for each to go through each age and add it to the array list and return. But the idea is we want all the ages to be returned as one array list. So you need to use a loop to go through the array list of ages, which is called adjacency list, and add all the ages into an array list object and return the array list. So this is really very easy to do. Okay, the second one is to write a Boolean method is age. We saw a method get age. If you give it v0 and v1, it will return to you the age if it exists, or null if it doesn't exist. So now the user is giving you two IDs, v0 and v1, and he just wants to know, does this age exist or not? Okay, so this should be very easy. You can in fact use your get age to answer this question. Does this age exist? I leave you to think about it. The last method you have to do is called isConnected. Again, another Boolean method. We want to know if a graph is connected or not. I haven't explained the meaning of is connected in detail in the lecture. We will do that in the second part. But the simple version of it is really very easy. As we saw in our examples of graphs, if I can go right to the beginning of this example. So this kind of graph, okay, is not connected, because as you can see, there is no link between this vertex and this one. Okay, and similarly from here to here or here. So there is an isolated vertex basically. Okay, whereas the others, they are connected. So the question is, write a Boolean method that if you give it this graph, it will say not connected, false. But if you give it this one, it will say true, it is connected. Now I have given you a very useful hint here how to do it. Okay, it's a hint. It's very similar to breadth first traversal. Okay, you're going to do breadth first traversal, or you're going to modify the breadth first traversal method. The only difference is when we visit a vertex, we're going to count it. So you will be, instead of visiting it, we will count. All right, so only that instead of visiting a vertex, you should increment a counter. At the end of your traversal, you shall compare your counter against the number of vertices. There's a variable that will tell you the number of vertices. So is your count equal to that? If yes, then the graph is connected. If not, the graph is not connected. Okay, so basically what we are saying here is, suppose you start traversal from here. Okay, so you visit this vertex, the successor is this one, so you go and visit the successor, and then you are stuck. You are able to visit only two, because this cannot lead you to here or here. So count how many vertices we visited, only two, and we know there are 1, 2, 3, 4, 5 vertices. So since the number of vertices visited is not the same as the number of vertices in the graph, it means the graph is not connected. As simple as that. Okay, so that's what you have to do. If we may go back to the code again, just to give you more hint. This is the breadth first traversal. Okay, everything is more or less the same, except that you need to introduce a count variable somewhere. Okay, before the beginning of this loop, you have to introduce a count. Now here, when you dequeue a vertex, don't visit it. Rather, just increment your count. Okay, now at the end of the loop, check your count against what? Number of vertices. Okay, so the method, of course, is not going to be void, it's going to be Boolean. Okay, as you can see in the document. So Does your count equal to the number of vertices? If yes, return true, the graph is connected. Otherwise, it is not connected. Okay, this is all you have to do. Just copy and paste this method, rename it as stated there, is connected, and Boolean as return type, and do exactly as mentioned here. Very easy, inshallah. Once you finish that, now you need to update the test class to test all your 3 different methods. Okay, so if I call this option, it will print all the ages in the graph. This one will ask you to input 2 values for V0 and V1, and it will tell you if there is an age like that. Okay, and this one will also tell you whether the graph is connected or not. This is the end of lab 10. In lab 11, I will be explaining this remaining task. That is it. Thank you very much.